This video covers single replacement reactions and the prediction of products. Remember, in a single replacement reaction, we have one element replacing the other. And there actually can be several different types of single replacement reactions. We will visit the reference table in a moment to discuss those different types of single replacement reactions. Here is your general equation for a single replacement reaction where we have A plus BC yields AC plus B. In this type of chemical equation, you will have your A switching with your B, and your B gets kicked out. This is normally going to be involving metals, where you have active metals replacing other elements in your chemical equation. Here's a good example. We have magnesium plus acetic acid yields magnesium acetate plus hydrogen. In this case, we're going to say hydrogen is pretending to be a metal, and magnesium is going to replace hydrogen and kick hydrogen out. So we have an element single on both sides. Another type of single replacement reaction we can have is this. This says D plus BC yields BD plus C. This type of chemical or single replacement reaction is where you're going to have non-metals switching places. Here we have D is kicking C out. Okay, so this non-metal has to be specific though. It has to be from group 17. Group 17 are your halogens, and your halogens include fluorine, chlorine, bromine, and iodine. So this is from group 17. Here is an example. Here we have bromine plus magnesium iodide yields magnesium bromide plus iodine. Notice how your bromine is replacing the iodine and the iodine is getting kicked out. Here we have two non-metal switching places, whereas at the top we had two metals switching places. Be very careful when you are looking at your single replacement reactions to decide who should be going where. Again, remember this bottom equation is for group 17 elements, and those are your halogens. Alright, so let's take a look at your reference table. This is page 6 from the North Carolina Course of Study reference table for chemistry. We are talking specifically about single replacement reactions. So here is single replacement. It is a number 3. And notice how we can have an A, B, C, or D. I'm going to go to the next slide so that we can take a closer look at this. We can have a 3A, which is a metal-metal replacement. This is where a general equation comes from, where you have your two metal switching places, where here A is replacing B and B gets kicked out. Another type we can have is a 3B. This is where you have an active metal replacing hydrogen from water. So here's your metal and here's water. That product will produce a metal hydroxide and hydrogen gas, and this is an H2 because hydrogen is diatomic. We can have a 3C, which is an active metal replaces H from acid. Here's our metal, and here's our acid. The reason why there is an X here is because this X can be a non-metal, such as fluorine, chlorine, bromine, or iodine, or it could be a polyatomic ion for your tertiary and oxy acids. Whenever you see an acid in a metal, you are going to have a single replacement reaction, and that's going to produce your metal plus your non-metal, or your halide, and then it's also going to produce hydrogen gas, and again, this is a 2. The last type we have is a 3D. This is what we just looked at on the last slide, where you have a halide-halide replacement. This is referring specifically to halogens. So this is group 17, fluorine, chlorine, bromine, or iodine. And this is where your halogens are going to switch places, and you'll have one being kicked out. Now, I'm sure you're wondering why this says active. Active metals replacing hydrogen. Active metals replacing hydrogen. When we're saying active, we have to specifically refer to the activity series, which can be found in your reference table on page 7. Here are your activity series of elements. When it says active metal, here's where you're going to find active metals. Now, what we have to pay pay close attention to is when we use our activity series, the element that is by itself needs to be higher on the list than the metal that's in the compound. We also have an activity series for halogens, and it works the same way. The higher on the list, the more active that element is. If your element that's higher on the list is by itself as a reactant, it will replace the element in your compound. And I'll show you exactly what I mean on the next slide when we practice a few. Okay, so make sure that you're looking at your activity series when you are completing your single replacement reactions. If an element is by itself, it will replace any lower element in a compound. Again, so you're looking for the elements on this activity series. The higher you are on the list, the more active your element is. So let's practice a couple. Here's number 1. We have potassium plus zinc chloride. And I want to predict the product for this. First of all, I know it's a single replacement reaction because I have potassium by itself. Okay, so since I have potassium by itself, I have to decide what type of chemical reaction this is. I'm looking in my reference table. I am looking at the single replacement category, and this appears to be a 3A. This is a metal-metal replacement. I know it's a metal-metal replacement because I do not see any hydrogens for acids and water, and I do not have 2 halogens. So, with that being said, potassium should replace zinc, and zinc should get kicked out over here by itself. So we should have zinc plus potassium chloride. When you are writing this ionic bond, make sure that you check your charges. Potassium has a +1. Chlorine has a -1, so their charges balance out. Now, to make sure that this reaction does occur, I need to make sure that potassium is higher on the list than zinc. Here's my activity series. Where is potassium? Here's potassium. And where is zinc? Here's zinc. Okay, so potassium is in fact higher on the list than zinc, so this reaction will occur. Okay, so let's try another one. Here is number 2. This is fluorine plus HCl. All right, I'm going to look at my reference table. I'm going to decide what type of chemical reaction this is. This is a single replacement. I do not have any metals here. So it cannot be a metal-metal replacement, or an active metal replacing hydrogen from water, or an active metal replacing hydrogen from acid. Even though I do have an acid here, I don't have any metals, so this cannot be a 3C. So through process of elimination, I have decided this will be a 3D chemical equation where I have my halogens, which is fluorine and chlorine, switching places. So what should happen is fluorine should come in here and replace chlorine, and chlorine should get kicked out. Now when I'm predicting this product, I'm going to write chlorine. Remember, chlorine is diatomic, so I cannot write just Cl by itself. It has to be Cl2. So I have Cl2 plus hydrogen and fluorine. Hydrogen has a +1 charge. Fluorine has a -1 charge. So my formula will be HF. Now to double check to make sure that this reaction occurs, I'm going to look at my activity series of halogens at the top here. I need to make sure that fluorine is higher in activity than chlorine. It is, so this chemical reaction will occur. Once I have predicted the product, I will balance this equation. I can balance this top equation too. Keep in mind that you are not going to carry over the subscripts for your products, okay? I don't have subscripts here because I need to check my charges. I do have a subscript here for this chlorine because chlorine is diatomic. So let's go back to 3A, this first equation up here, and let's balance it. I have 1 potassium on my reactant side, 1 on my product side. I have 1 zinc on my reactant side and 1 on my product side. I have 2 chlorines on my reactant side and 1 on my product side, so I'm going to put a 2 here for a coefficient. When I did that, this coefficient makes it so I have 2 potassiums as well, so I'll need a 2 over here to have this to be a balanced equation. Okay, so let's look at this next one here. I have 2 fluorines on the reactant side and 1 on my product side, so I'm going to put a 2 here to balance that out. I have 1 hydrogen on this side and 2 on my product side, so I'm going to put a 2 here to balance this. I have 2 chlorines and 2 chlorines, so I'm balanced. So always predict your product first. Do not worry about the subscripts. You write the subscripts according to how the charges cancel each other out or how the bonds are being made. Then you can go back and balance your chemical equation to make sure that it is right. Let's do one more before I run out of time. Here we have iron plus sodium phosphate. I'm going to decide what type of chemical reaction this is. After looking at my reference table, this is a 3A, a metal-metal replacement, where iron should replace sodium in this chemical equation. If I look at my activity series over here, I'm going to find sodium. Here's sodium. And I'm going to find iron. Here's iron. Now remember, the element that's by itself needs to be higher in activity. In this case, though, it is not. Therefore, this reaction will not occur, so we're going to write no reaction. I'm going to abbreviate reaction as RXN. Okay, it looks like I have time to do one more. Okay, here we have Li, which is lithium, plus water. After looking at my reference table, I've decided that this is a 3B, an active metal replacing H in water. Okay, so lithium should do this, and my product should be a metal hydroxide. Well, my only metal here is lithium. Lithium has a +1 charge. Hydroxide has a -1 charge. Those charges do balance out to equal 0. So my formula will be LiOH. My other product here will be hydrogen, H2. I'm going to double check to make sure that lithium is higher than hydrogen, and it is. Here's lithium. Here's hydrogen, so this reaction will occur. And now it's time for me to balance this chemical equation. I'm going to use MnO, metals, ions, nonmetals, oxygen, and hydrogen. So lithium first, since it's the metal. I have 1 lithium on my reactant side, 1 on my product side. I'm going to do my oxygens next. I have 1 oxygen on my reactant side and 1 on my product side. And then I have my hydrogens. I have 2 on my reactant side and 3 on my product side. I'm going to put a 2 here. Remember that this 2 is going to distribute to everything. So now I have 4 hydrogens on my product side. To fix that, I'm going to put a 2 here. So now I have 2 hydrogens, or 4 hydrogens here as well. So since I placed these coefficients, I'm going to recount all of my atoms just to make sure that I've balanced correctly. And I noticed that I haven't. I do need a 2 here as well. So I have 2 lithiums, 4 hydrogens, and 2 plus 2 hydrogens is 4. 2 oxygens and 2 oxygens, so I am balanced. I'm going to do this last one down here at the bottom for you.